So today's program is decimal octal number, DeciOct or decimal to octal number. In this program, we basically convert a number from decimal to octal. The base of the number changes. Like decimal is number system in which there are 10 digits from 0 to 9, and octal is, of course, as its name is, octal 8, 0 to 7. So we just convert from this with 10 base to 8 base, number from 10 base to 8 base. The theory of this program is, like, the concept of the program is very simple. Just the way we implement it, we will implement it in 3 ways: one using iteration and 2 using recursions. So let's first take an example. So these are 2 decimal and octal numbers, 0 to 11 and 0 to 13. Since there are no 8 and 9 present in this number system, after 7 comes 10, which is the combination of next two, like first 2 digits, which comes next, and after that we just keep changing remixing the other digits like we do in decimal number. Like we keep mixing the same digits and keep forming the single digit, double digit, and then 3 digits. This is the same as how we convert from decimal to binary. We just divide by the base of that number system. So if we are converting from decimal to octal, we divide by 8, and if we are converting from decimal to binary, we divide by 2, and it leaves with a remainder. For example, if I'm converting from, let's say I'm converting 10 from decimal to octal, so it should be 12, but you are not gonna calculate like this every time. So what you do is you do modulus. We find modulus, which is this symbol. What it does is it leaves remainder. So if we are dividing here, for example, if we're dividing 10 with 8, we'll divide it 10, 8 1 8, it leaves the remainder 2. After that, the quotient is transferred to again to be divided. We take the remainder here, 2 gets transferred to behind the number, and then 1 is the quotient that's left. 0, we cannot divide 1, so we put in 0. 8 zeros are 0, we get a remainder of 1 again. So we add it in the front, so add it in reverse, so it will come 12 with our base 8. The base of the number changed. Now let's take a real example, like an actual number which is actually hard to find, kind of. So this is an decimal number, this converted to octal. Let's go. So decimal to octal, yes, this is the right one. So 125 we divided by 8, here 15, and we are left with 5. The 5 gets transferred here, and then we had 15 left. The 15 becomes a quotient, 8 1 8, and we get the remainder of 7. Remainder of 7, 7 comes, remainder of 7, 7 comes here, 7 comes here, yes, 7 comes here, and then quotient is transferred right here. So then we divide the quotient by 0, and 1 comes right here. So it keeps getting added in the front. So 5, then 7 came, it got added in the front. Then it's 75, after that 1 came and it got added in the front. So that's how we convert. Now there are 3 ways I'm trying to implement this program. First is using iteration, iteration is basically we iterate from 0 to, or between starting and end position, and it keeps increasing. In recursion, we have a statement and we call that method again and again until that statement breaks, and we have the base case, which basically generally just returns or calculates the final output. And then there is this DeciOct. This is even a bit more advanced at recursion, which method is called, and it is even more complicated kind of, because it's using math.pow and it's all these brackets, etc. So let's break all three of this program and by line. Like, this is the simplest one. Scanner, we take an input and we just take an input in, and we declare a few variables for our work. Int octal number, for Z for another temporary number, z it's converted into string, and it's another string. So why do we need strings? Because to add a number in front of it, the best way is strings. Like in this, both of these are string, and the best way is to just place it like strings can add. That's why I've written this in the form of strings. It is very easy to add the strings wherever you want. Like if I wanted to add it after, I would just have placed a plus sign and added it right there. So that's why we use strings. We just find that, like, for it's iterating from 1, like 0 to, no, it is iterating from that number to until it is greater than 0. I mean, until it's 1 here. So, and then, no, it's until it is positive number, and then we are removing 1 bit from the number bit by bit. So how this goes is we're modulating it by 8. Okay, perfect. Yeah, so we are just taking the remainder here, which we were taking here. Like, we are dividing it by 8. We're taking also remainder here 8. So if you divide it by 8, it changes to whatever the quotient is, and the modulus, it takes the remainder, and then we take the remainder inside another string. We convert the integer into a string so that it can be added into another variable in whichever order that we want. And then after that, after all, we convert it back to integer and display it. That's how we do it. Okay, so basically we just use a iterate through whole of the number while dividing it by 8. We take the modulus to get the remainder, and then we use strings to concatenate the number, or just join the numbers, and we just convert it back and forth. Once this program is done, let's go through another program. This uses objects and methods in a much better way, and like calling, etc. So let's simply we create an object to take input system.in, then we declare a few variables for our work. After that, we take this. These are methods. This is a constructor. This is initialized when creating another object for our purpose. Get number, and that is taking the input, that is transferred to get num. Get the number, it declares the number here, and then it calls the method show. Method show calls DeciOct, which is the main recursion method. So z and zz. Z is the integer and zz is the string. If x is greater than 0, until it is positive, we keep on doing the same, because every time we are dividing. Okay, so we take the remainder here, convert the remainder to string, and then we add. Again, we call the method. This is what recursion is. We keep calling the method to do our job simply. And then after it is like greater than 0, like when it becomes 0, so we call the base loop, which is the else loop, and the string is converted back to integer. That's how we do it. Like, so to understand this, basically the most important thing is how you will convert string to integer and integer to string. Otherwise all the concepts are very easy. You just remember where to, you need to place that number. It's always in before the original number, the before the number that is already present. You can see in this example, like 75 is the oct, because 75 is what the result that we got in the previous iteration. After that we add ahead of it, such that it is added ahead of the oct. So, and then since it's recursion, you have to call the method, and then it will call again until this is no longer true. And in here, this is just another way of recursion. Everything else is the same. Here we do n is equals to n by 8. This is modifying the condition every time, and this is the only change that there is. So how are we adding the numbers every time in that string? We were using string to add that number, but we can do without string. You see, after every iteration, like it's not iteration, this is recursion. After every time this method runs, so this 5 is at the position of 0, gets added at the position of 0. This 7 gets added at the position of 10. This got added at the position of 100. So you can see that if we would have multiplied 1 by 100 and then added 7, the previous number, it would have worked. If you would have multiplied 7 by 10 and then added the previous number, it would have worked again. That is exactly what we are doing here. And I++, because 1, there is always increment of 1 while going through each step. So that's basically what we are implementing. We are using power to do that, math.power of 10. Every time, like, we are increasing, like it's 1, then 1 0 came, and then 2 0 came. Okay, so first it will be 0, 10 dot power 0 is 1, then it will be 10, and it will be 100. So we can, math.power is a decimal, so we have to convert it into integer, and after that we multiply it by the number that is coming next. Okay, oct, this is, we are using shorthand. Oct plus is equals to this, so oct plus, like, because we are making it a sum, it doesn't matter which order we put it in, because in sum everything adds up like that way. So we're just increasing the increment of that number and adding it right here. After that we are using recursion, so we call that method again until this is true. We keep running it. There is no base loop, it just terminates and we get the answer. We could have added the base loop, but it will run without it, so we don't need it. We should have added it, but yeah, it will run without it. Okay, so this was it. Let's run all of these programs once, just for checking to see how things function. What a decimal number? Decimal number is, let's enter 10. Its octal equivalent is 12. Let's enter 125. 25 is 175, perfect. And let's enter 4. Octal equivalent is still 4. So this was the decimal to octal number conversation program, Java program. I hope you understood it. Thank you.